Let's try to solve syllogism using an example first. A very simple example to start with. All dogs are cats. As I told you, you have to leave aside the preconceived notion and we'll just assume what is given. So all dogs are cats. Okay. And the second statement says some rats are cats. Okay. So these are the two statements given. And then I have been given a set of 3 conclusions. So these are conclusions. We have to find whether the conclusions are correct or not. So let's start. Let's start solving the problem. So how do we solve this? We'll use a 2-step approach. The first step is, whenever the problem is given, we'll make the basic diagram first. So using the 4 cases which we had studied before, we'll try to form the basic diagram. Okay. Basic diagram will be formed such that there is minimum overlap. Once the basic diagram is ready, we'll try to find the conclusions if they are correct or not. If they are false, then upfront we'll write it as false. If they are true, then we'll go to the second step. We'll test, is it true for all the possible diagrams or not? Then if it fails for any particular diagram, then it's false. But if it is true for all possible diagrams, then it is true. Okay, it sounds very complicated, but believe me, it's not. And with practice, you're going to get better and better. Let's see this one. So we have been told all dogs are cats. So we'll start with the basic diagram. Since all dogs are cats, so cat is the superset. So I'll draw this first. Cats. And then I'll draw subset dogs. Okay. So all dogs are cats. Outside there might be some cats which are not actually dogs. Correct. Now the second one says some cats are rats. Minimum overlap. So we'll make one more. Maybe I should use a different color. This represents rats. So there are some rats which are actually cats. So this is the basic diagram. Now we'll try to test the first conclusion. Some rats are dogs. Since we are drawn with the minimum overlap, we didn't overlap rats with dogs, right? We wanted minimum overlaps. So basically, you can see easily from the basic diagram, there is a possibility that rats are not actually connected nowhere with the dogs. So some rats are dogs? Nope. It fails the basic diagram. Some dogs are rats. Again, you can see from the very basic diagram, this conclusion doesn't hold true. So this is again false. Third one, some cats are dogs. Now from the diagram we can see there are several cats which lie in this dotted area of dogs when they are actually dogs. So yeah, from the basic diagram it looks like the third one is true. But let's test it. Now when we say all dogs are cats, there is one more possible diagram. When say this is my cat and the same thing is my dog. This is one more possibility, right? In this diagram, is it possible some cats are dogs? Yes, some cats are dogs. So even for this possible combination, the third conclusion is true. So we can say for sure, yes, the third conclusion is true. So did you see? We took a 2-step approach. We drew the basic diagram first with minimum overlap. And with that basic diagram, we were able to say that the conclusion 1 and 2 are false. Then for the third one, we saw that the basic diagram said it's true. Then we went to the second step. We tried all possible diagrams, and with all possible diagrams as well, we saw that yes, the third conclusion is true. Then, only then, we concluded that the third one is true. So this is the two-step process we'll be following for all syllogism problems. Let's move on to the next example.